which you will also see later. And for the other users, for example, somebody use R, somebody use C++, you can try to expose the Google Earth Engine with API, your own APIs. And if the visualization in the GEE is not up to your need, you can output the data from GEE and visualize the data with Kepler .gl, which is a very powerful tool. You can see that in the lower right corner, there is the Kepler GL. And the fourth advantage of GEE is that it contains a lot of data. So in its slogan, it's petabyte worth of data sets. And last but not least, for non-profit researchers, GEE is free. So if you are not doing commercial projects, you don't need to pay any money for all this service and data. And let's begin with the basic. So satellite images and the data. So in order to analyze, you need data sets from GEE. So what is a data set? So it helps to imagine the whole situation like a stack of data on top of a map. So on the right-hand side of this slide, at the bottom of the slide, you can see that the continent of Africa. So you have like the Earth surface, and then different satellites or different satellite missions will go over the region and take different images. They take photos or other stuff. And then they will process these photos into a data set. And different satellites will have different measurements, different data. And they put all into Google Earth Engine data catalog, which you can search in the browser. So you can see that on the right part of the slide. So for example, if you want to monitor the tropical forest, you can go to the Earth Engine and search, and then you will find this data set. So there are two types of data sets. The first is image, and the second is image collection. They are actually very easy to understand. So you all know computer images. To make an image, you need an RGB channel. So you need a blue, you need a green, you need a red channel to make one computer color image. It is similar in the satellite image. Only in satellite image, you have way more channels or way more bands than just RGB. So you can have a near infrared channel, and then you can have other data channels. So they, some other channels, they may not even have like a pixel images. Instead, they have either measurements like elevation or the vegetation index values. But nevertheless, conceptually, they are the same. So you have multiple channels in one image. For some measurements, such as the elevation of the land, it is enough for you just to take one image because it doesn't change. The elevation doesn't change a lot over time. So for elevation, it is it suffices for you just to pick one image. So that is the image type. But for other observations, which takes place over time, for example, the climate change, the atmospheric composition, and like the land use type, they will change over time. And so you need a time series. So you need a series of images to capture this change. And in that case, it is not enough for you just to take one picture. You will have to take a series of pictures. And a series of pictures make an image collection that is on the right side of the slide. So as you can see in this PowerPoint, that for image collection, you will have a different collection dates, and each day will collect one image. from the same area. And you can also already see which type of data set it is in the data catalog. Because in the web page, you will see EE image for image type and EE.image collection for image type. So you will already know what are you working on, what are you dealing with, just by looking the example code on the Google website. To load these two types of images are also very similar. You just need one line of function, and Google will already load this image into a variable. For example, in this case, I would like to calculate the elevation of the world. I will use the NASA data set for this purpose, and then in this one line of code, so with the EE.image function, I can load the one image into the memory, and then I can use it later to calculate the different elevation of different type areas. And to load an image collection, it is not much different. It has some more small functions, but it is conceptually also very similar. So the first line, it is that you define the data set that you want. For example, in this case, I want the Morris data set for vegetation. So I will load it with an image collection function. And in this case, because an image collection takes place over a period of time, and in this case, I only want a certain time range. So I will have to define a start date and an end date. So I do not need to load all the data. So because it can be a very huge data set, but I only want a certain time range. So I filter the date on the second one. And then the third line, it defines which channel, which band I need. In this case, I just need the two vegetation indexes band, the NDVI and the EVI. So I just need these two bands, so then I can have a very small data set, and it can be faster in the process. And also, Google Earth Engines allowed function chains. So after the filter, after the select, you can actually add some pre-processing to the data set. For example, in this case, I want to scale the pictures. I want to divide them by 10,000 to scale the pictures, and I also want to add a timestamp to each image with the first time of the date in the daytime. So after the loading of, do some so-called reductions. For example, if you load an image collection, so it will be like over a year. So each month you will have a picture. So for 12 months, you will have like a 1 year worth of data. But what if someone comes and asks, can you give me the average of that year? I don't want each month, I just want also called the composite image to deliver the answer. So in this case, for example, if you have like a land use case, you will want to tell the one that who asked the question said that this pixel in this year is most likely to be the class 0, because there are the 0 comes most often. So in this case, you will do a mode operation, a reduction. So on the other pixel, if the 7 comes up the most often, then for that pixel, 7 will be the composite pixel for So for each pixel, basically you have done an overtime calculation. So you compress the image over time. You just tell people that what is the most often pixel in that year over the 12 months, and then that is your final answer. For the elevation, so how high are the landscapes, and you have different heights for different pixels. But if someone comes again and asks you what is the average height of that area, instead of telling him every value in that area, you want to have a mean value of the whole area. So in this case, you will want to do a horizontal reduction. So you will reduce the whole area, all these 9 pixels, into one average pixel. So that is over the space. With all these basics, let's if we are interested in the vegetation of a certain region, we can modify the so-called vegetation indexes. So we have EVI and NDVI to reflect how healthy are the vegetations of a certain area. So in this example, I've shown you an app that can measure this. So the user will use the drawing tool to define a geography on the map, and then the app will calculate the average EVI and NDVI. And then it will plot this EVI and NDVI over time, so that you can see how the vegetation changed in this period of time. So the first part of the example is how to load the data. Again, first I define a region, an area of interest, and then in the second part of the code, I load the images. Image collection. So in this case, again, it's the modest, and I filter the dates. So I only want the data between 2017 and 2022. And then the last line, it tells Google Earth Engine that I only want the NDVI and EVI bands from the image. And just as simple as that, 3 lines of code, I can already load the whole data set into the memory. And then once I have that data set, now I can do the charts. So a time series chart. So on the left hand side you will see the code, and on the right hand side you will see the graph that this code produced. And the most important part of this code is the first part, so the chart image series. So at the beginning of this function, you will see that this function takes the image collection I have just loaded, and then it will also ask which region that I'm interested in. So it's the square I draw with my drawing tool. So the geometry in this case is the region I'm interested in. And because I want only one EVI value and one NDVI value for each single time point, I want the mean of the whole area. So I do not want a lot of numbers. I just want one number for one time point over the whole area. So I will have to do a reduce with the mean function. So that is the 4th line. And then the scale means that it is the sampling takes place over a 500-meter area, and so on. And then the rest of the code defines how the graph looks like. So the axis, what is the legends, and so on. And the end product is on the right hand side of the slide, as you can see. So you will see a time series graph and reflects the seasonal changes of the vegetations. And you can see both the NDVI and the EVI, they agree most of the time. So you will see the peak together, and you will see the values together. But of course, since the two indexes measure the vegetation a little bit different, there are some minor differences, but the trend is the same. So both the EVI and NDVI reflect the seasonal change concordant. So I would like to also then show you that on the on live, so with a demo. So let's say this is the app in the Google Editor, and let's say here is Germany, and then I would like to just measure a new area. I just need to draw a new area, and then the Google Earth Engine will update this plot, as you can see on the right hand side, and then it will also calculate the thumbnails for the whole area. So as you can see, it will show you how the situation at each time point. So in this case, the greener the area, the higher is the vegetation value. And as you can see that this MODIS data set, it has a very coarse grain granularity. So the area is not very well defined. So this is one feature of the MODIS data set. It has a very complete coverage of the whole time, but the resolution is quite bad, so it's not very high. But if you want some high resolution results, you should change the data set into, for example, with the Copernicus. There you will have a much better resolution over the area, but the Copernicus will have many gaps in the time, so you sometimes have some sections missing in the graph. So there are both advantages and disadvantages of the MODIS and the Copernicus dataset. So with these examples, we can then we can expand these examples a little bit, because then if we can calculate the average, the area of the vegetation, can we calculate, for example, other features, for example, the water bodies? Can we measure the size of the Dead Sea over time? The answer is yes, but in order for us to measure a certain land features, for example, water, desert, and so on, we need a so-called LULAP dataset. So land use and then land area. So there is a dataset called the Dynamic World from Google. So they have done the land classification so that we know that each pixel, is it water, is it vegetation, is it a building, is it a desert, and so on. And then we can filter the land use type, and then we can count how many pixels are there. For example, if I'm interested in water, I can count how many water pixels are there in the region, and then multiply that by the pixel area to get the average, to get the area value of the whole area, of the whole water body over the area. And I will also want to demonstrate this app to you. So now we are looking at the Nairobi area. So let's say I want to measure the water area of the lake Naivasha. So in this case, I will draw a rectangle over the lake, and then on the right hand side, Google Earth Engine will display the results. So first, it shows us how the water area changes over time. So that is the area values. So as you can see that the area actually increased from 2017 to 2022, and you can see the details in the thumbnails below. So as you can see that over time, the water area, especially in the northern part of the lake, has increased steadily. But in this case, we also need to consider whether the cloud has interfered with our result, because images have a very high cloud percentage, which may reduce the measure area, so that may lead to a wrong result. So it helps for us to validate these results with other measurements, such as on the ground measurements and so on, and also to see whether the global trend, the long-term trend, is really like this. So the image itself is just one source of data, one data source. So we should confirm this observation with other data sources, and so then we can make more accurate conclusions. So that is the app also allow us to do other analyze. For example, we can also measure the trees and grasses and crops and so on. So that is the measurement of the water body and land use, other land use. So we can use this technology to do more. So if we can measure the area of the water, we can measure the top area. So for example, with the USDA NASS dataset, we can actually measure the cultivation area of different crops. So in this dataset, we can find the corn area, the rice, the soybeans, and so on. So we can actually measure the cultivation area of these crops in United States over time, and then we can correlate the cultivation area with the production of the crops. For example, in this case, I have the corn production in this table. So this area value comes from Google Earth Engine by using this dataset, and then the corn production value comes from the America, also the NASS service. So they provided the agricultural output over the year. So with these two columns at a time, we can do a correlation to see whether the production and the area correlate well. So in the case of corn, we can see that the R square is very low, which means that the area, the cultivation area in corns doesn't predict the production very well. However, the R square for soybean is quite high, which means that the yield of each soybean area may be very stable. So you can predict the soybean production based on the soybean cultivation area. So with this knowledge, we can then monitor how many soybeans are planted next year in the United States, and then we can predict the soybean production next year. It is good to use all this online app, but however, we can only measure a very limited amount of features over certain regions. So the question is, can we have a very big overview of the region without just doing the programming? Can we just have this data displayed interactively, and then we can also look at the details of many parameters? So in that case, we then need to export the measurement data from Google Earth Engine and then use another app called Kepler.gl to do the analysis. So in this project, I have tried to collect many different data sets from Google Earth Engine. So I want to measure the precipitation, so the rain amount, and the offline methane, land surface temperature, and the primary production and elevation and so on. So I have written an app for this project, for this purpose. So this is the app. So in this app, I will have like the map area, and then here is the control element. So now let's say I want to measure all those things in the table around Nairobi. So then what I have to do is I have to draw a square, a rectangle over Nairobi, and then Google Earth Engine will try to calculate the area, and it will calculate all the information that I need, and then I can generate a download link for this area. And then once I downloaded the data, I will go to the Kepler.gl, and then I can upload the data from Google Earth Engine, and then it will first display a grid of dots. So because Google Earth Engines I have to sample the dots in equal distances to represent the area. So in this case, I have all the sampling size from Google Earth Engine, and now we can control. For example, in the pop-up menu, you can see the values for each sampling size. For example, for this location, we have the EVI value of 0.24, and we know that it is a building area. So because in dynamic world LULAC, you can see the build, and also it is 2,123 meters above the sea level, and it has a primary productivity of 307. So, but now we have way more values than these measurements, and we can add this measure also into the pop-ups by going to the tooltips and add all those features. And once we add these features, we can see that the pop-up menus now is much longer. So we can now also see the NDVI value, the land surface temperature, and so on. But the display in the same color doesn't tell us much. In fact, we can change the visualization easily in Kepler by going over the layers, and then in the view color, we have to change how the color will change based on which character. For example, let's say I want to measure the EVI, the vegetation, and then I can change also the color scale to reflect the EVI value. So for example, in this case, the greener the area, the more vegetation is around the sampling site. So by just doing this visualization, I can easily see that in the area of Nairobi. So in this central region, you have a lot of vegetation, while the other area, so in the southeast, the EVI value is much lower. So you will have more greens in this area than in here. We can also do the same, right? We can also visualize the other stuff, for example, not the vegetation, but the methane. So we can see that the methane PPV, so deeper the color. So for example, in this area, so I think that is where the population is concentrated. It has a higher methane concentration than the forest area. So with this visualization, you can have a very good, very fast overview over the whole region, and you can then also filter the data. For example, you only want certain value to be seen. For example, the EVI, you only want to show the region that with high EVI value and how they look like with methane. And then you can you can filter the data on this filter, so that you will have like a selection of pixels instead of all the pixels all at once. So you can further customize the display in Kepler. So as I've said, Google Earth Engine programmers that write in other languages like R, like Rust, and so on. So the question is, can we let them also use Google Earth Engine? The question is yes. So in this project, I use the Python Fast API to expose the Google Earth Engine service to the outside world. For this project, we only need Fast API and Angular. So basically, you need to just write some functions, which is very similar to how you do it in the other Google Earth Engine scripts. You just need to generate an image collection, and then you also filter and then select the bands that you need. And then once you have that, it then comes to the Fast API part. So in this case, I define like two routes. One is for the land surface temperature, and then the other is for the soil pH. So in this case, I will need to define how they interact with the user. So for example, if the user wants to know how hot or how cold is the land surface, we will call this API route. And then this API routes will call this function, get land surface temperature. And this function uses the Modis data set again. And it will pick the data, the geometry from the user, so the longitude and the latitude, and then calculate the surface temperature, and then return the result in the JSON format. And once you have this function implemented in Google Colab, you can set up the API via the Nubicorn and Angular. So in this case, for example, I have the service already up and running. So it is in this URL, and then once I enter this URL in my browser, I get the answer as a JSON format. And then if you are using the other programming language, then you can just use this API to fetch data without writing any Python or JavaScript code, so that you can expose the GE service to the other programmers, your friends, and so on. So you can, once you have this API, you can do a lot of stuff. For example, in this project, to calculate the area, temperature, and the pH values for certain area of interest. And once I have these values, I can do, for example, to see whether some bacteria are really growing according to the theoretical value, so that I can compare the results with the literature and so on. So after this introduction of these projects, I would also want to ask the audience for some advice, because there is also challenges in GE, because even though it is very powerful, but still there are some projects that require way more calculation and storage than GE can provide. For example, let's say I have a project, I have some sample already, and I ask you, where can I find a similar location on Earth? Can I find another place that has the same vegetation, the same elevation, and the same rainfall? So how can you do this? So the logical way of doing this is that you need to divide the Earth, the globe, into many small grid tiles. So each tiles represents a small place. And then you need to calculate all these data. So the forest, the rainfall, and the elevation. And because the Earth is very big, so you have to do a lot of this calculation for all these small grid tiles. And then you need to store all this out into a place. And then once you have done all this, okay, then I ask you, where can I find a similar place like the one that I already have? So just like Google search, can you give me a similar place, like Nairobi, for example? Where on mentioned in these articles. And finally, I want to thank the organizers and all the audience for your attention. And I would like to learn more also from you guys. So thank you.
Okay, so thank you very much.
Thank you, thank you.
Your very presentation. It's really wonderful and exciting, especially now that you have talked about the Nike API and the Gateway API. That's something, to be honest, I didn't want to it, and I'm learning something new today. So thank you so much, Lizzie, for this. So at this time, we are going to have a few questions which I believe our audience will be having. Now, one of the questions was somebody here in our team was asking is about the sharing of the presentation, of which now that you have already made it, we will also have the article about this presentation, about this talk in our blog. Our co-organizer Christopher here will share with you the link to our blog where we will be able to get all the presentations which for the previous event and also this one and the subsequent coming events which we are hoping to have. So we are really much grateful. And for the audience, Kenny has mentioned something very interesting here. What 3 meters that I had not worked about that, but this is really nice and we really appreciate this community because we can learn more from each other. So we are really grateful. So should we be having some questions, please you can type them on the chat, or you can raise your hand, or you can even speak here. It's really nice. So Kevin, you can share with us something about what really what if you watch much. I give you a chance, please.
Thank you.
Yes, you are audible.
Okay.
Yes.
In my case, as a junior developer, I have had some experience with what we want. It's a website, what we want to perform. It's a website that I actually use for map. Okay, what we want. The 1 into 3 by 3 meters, and the first 3 by 3 meters are displayed uniquely with 3 ones. So wherever you want, it can be what you want to do. You must be like this in one. Sure, if you lighten up our one, then it will be action on the finger. So we can material and business that it has some adult integration into the market. I believe that can be complete for somebody can leverage that we can favor someone.
Alright. Yes,
Yeah. I think he is referring to the challenge on Sixing Huang, the challenges, the first challenge.
Yes. Yes.
So I see that in your in the chat that you said that there is what 3 words. So
Yes.
is it I will check it out. Thank you. Because
thank you.
because there are some European power companies. They want to say so what if I want to make a new like a windmill? So they want to, for example, set up a new factory. So they want to have a site selection. So I want to select a certain site that have this innovation, that will have this intensity of wind and so on. So can you give me a location? So where should I open my next Starbucks and so on? So they have this question, but how can you do this for many remote areas? That is the question. So if this what three words can help, that would be great. I will try that. Thank you.
Yeah, we need some help. You're welcome.
Okay, so thank you for that clarification. So I believe what we are doing here is of benefit for many of us who have been in the tech space, because now you can see that Kevin is coming here with in the area of web. And for the Google engine, what you will say is that it's a cloud-based platform, because it's, if you have skills in cloud and you are good in development, it is a good fit for you. So it comprises of everybody, regardless of which you are in the mobile, you are machine learning, you are in web dev. This is something which can benefit all of us. So everybody is much welcome to learn with us, and we are really much grateful to be having you here and for having some time to share with us. So at this time, I'm going to give a chance to our co-organizer, Christopher, so that he can share with you some few items he had. So welcome, Chris.
So hi everyone. Yeah, so I'm
Alright.
Christopher, the co-organizer. So regarding the presentation, it was very good. I got to understand that we have an API. I didn't know that you can create one. Yeah, so thank you so much, 61. And another thing I needed to ask was there is this software, I think deep something dot YR, the one you are using to get data from the Earth engine. So is it free? Does it have a free version or is a commercial for businesses?
So the question is whether there is a free version or there is a commercial version.
Yeah. So is the software free for users to use or for researchers?
So there is actually introduction in here, so that you can see immediately that it has a clear definition. So saying what is so let me see it is free for non-profit. So basically everything that for researchers and for education it will be free, but for the commercial usage you have to acquire a commercial license. So as you can see in here. So yeah, it is in the terms, and you can see that non-commercial, yeah.
Yeah,
So you
thank
have free and then yeah.
Yeah, so thank you.
So-
So I was asking about the other one, you are getting data from GE after you download, then you upload it there, then you can see the map of Nairobi.
Yes,
Yeah, the other one.
yes. This
Yeah,
one
yeah.
is also free.
Oh,
This
it's
is
also
a
free.
Kepler GL.
Yeah.
Yeah, you can also use it for free, and you can also, as you can see in the front page, it is also on GitHub, so it is open source. So you can have all this also for free, and you can also do a 3D representation and then just the 2D. So so basically the whole the ecosystem is free.
Okay. Thank you so much.
You're welcome.
So thank you so much, Nicholas, for having organized this. So I'll be sharing the link to our blog on Dev2 and other social media platforms. So in a minute. So
glad that we stayed friends. Of
So in a
course.
minute, sorry.
Sorry, hang on a second. Not now, Rusty. Your love letter will have to wait. Oh, so Rusty's the one with the crush.
So Nicholas, you
Yeah.
can take over. So as I share the link, or Michael.
Look, your mom's here. Welcome for my friend.
Yes. Thank you, Christopher, for that nice comments. I want also to take this opportunity. I hope you can hear me, right?
Yes.
Oh yeah. I want to take this opportunity also to thank Six In Han for that nice presentation.
Thank
I
you.
really believe that we have learned much today. Actually, I had heard of Kepler, but I haven't used it. I didn't know it was that so interesting. I think now from this presentation, I'm going to be able to use it at least and see how the results come out. Otherwise, it has been a very nice presentation. Much to learn, and there is also still much to learn in the coming presentations. So being co-organizers, this community will also actually invite all of you that you come in during the next presentations, so that we can be able to learn even much more. So thank you so much.
Thank you.
Okay, so thank you very much, Michael. As we wait for Christopher, so just a brief introduction about our community is that it is a community of Google Earth Engine developers. We are all from different backgrounds. Myself, I'm a data scientist, and Michael is a geospatial developer. But for me, I'm a data scientist who has moved to geospatial data science, which now this incorporates use of satellites and imageries and the Google Earth Engine. I've also I've operated in the background of IT, so all these things are good with me. Previously, I was using the AWS cloud, and now these days I'm using the Google Earth Engine cloud, Google technologies, and we have all the knowledge about the Google Cloud, AWS Cloud. So we have the background in tech, deep in tech. So myself, Christopher, Michael, you can ask any question regarding to Google Cloud, AWS Cloud, even data science, machine learning, all those things if you are interested in such kind of things. So here is where we get to share all our knowledge, we get to share our experiences, we invite our speakers. So occasionally we'll be having experts talks. Like the previous event, we had an expert talk whereby we had the introduction about all what is about GE. Next, we are going to have, now today we had the hands-on session now, which we have already handled here with guidance from 6, and it is really much interesting to have such excited speakers who share with us and are really willing to teach us these great technologies. So we have a mix of experts which are horror talks and also hands-on. Like now for the today it was on hands-on. So we are focusing the next Saturday, which is going to be, we are going to have a hands-on session still, but now moving things a bit higher. Not again as the introduction. This was an introduction, a small introduction about how to read data, how to do some pre-processing, such kind of. This was an introduction and getting starting. So next step, we are going to move the next step about it, and we are looking forward to have a community which is really informed in the next few months. Like by June like that will be fully fully understanding of working on a serious based project. So we are looking forward when we train and we get to have everybody is at a good point. We'll start working on a small project, simple project, then so that we can get to have each one of us able to work on a project by himself or herself. I think this will really help each one of us. And we are not charging, this is for free. We are sharing knowledge. Like now you can see today we have learned something new from Kevin, which we really appreciate this kind of interactions. They are really much helpful. So by maybe June we'll be coming here and working on a small project, and then we review all of us together. We get to learn such that you yourself, having come here, you can handle a project by yourself, which I believe it will really help all of us. So this is our dream, and we look forward to having you in our subsequent events which are coming up. So in this case, we have our social media pages whereby you can reach out to us and also to anyone who you would love to share your knowledge with, you would love to ask, you would love to have anything. So in that case, Christopher has shared some links in the chat box. So I think, Chris, you can talk more about that, please, if you won't mind.
Yes, yes. So I've shared the link for our Dev2 account. So we have not yet published any article regarding
Yes,
the.
please.
Oh, sorry. Sorry.
Sure.
Sorry, I forgot. I forgot. So I shared the link on Dev2 account, but still we have not yet published any article on it. So we'll be sharing on the subsequent presentations last week, this week, and the ongoing ones now. So you can follow us there so that you can receive notifications on the same. So on our other social media platforms, we have Twitter and LinkedIn. So I'll be sharing. I think Nicholas, you can share the other two for LinkedIn and Twitter. Just a minute. So we'll be having more speakers from next week every Saturday. So keep watching our platforms. We'll be sharing also on our pages. So let's keep learning. This is a nice platform to get knowledge and advance our skills. Yes.
Okay, so next we are looking forward to have a group, but not a WhatsApp group, but we were thinking of a Google group, which now is much easier, for which you only need your email, you don't need your WhatsApp numbers and everything. We were thinking of that because, and also it's big enough to accommodate most of us. So we are thinking of that, and it will be soon launched, whereby you can be getting some notification of anything, but any communication is shared here in that email will only be regarding the GE things, GE communities, GE, anything to do with GE. So we are looking forward to have that soon, and it will be launched. When it is ready, we will share with you, and I believe it will be of benefit to all of us. So for me, I am okay. I'm not having any.
What is that?
Okay.
Yes, please.
Can you share with me?
Sorry?
Yes.
What's it?
Yes, Nicholas.
Do you know
Yes,
you're not supposed to be having this?
I think. Hello. So I also have something to say.
Yes, please.
Yeah, from the charts, I can see Sittingham has asked about land use classification.
What's that?
Oh,
Don't get used to it, right?
Oh, yes. So actually, from
These are just
I think I
color.
can speak about it a little bit so that maybe I can explain it.
yes, please.
Yeah. So land use, LULC actually in full is land use land cover classification. Basically, this is we can perform either supervised or unsupervised classification. All of these functionalities are actually provided in Google Earth Engine platform. So, for example, if you choose to do supervised classification or supervised learning, we'll be able to use probably we can be able to choose the already available models, random, for example, random forest or support vector machines, or we can even use decision tree to perform classification. And so basically, land use land cover for this case, this is just going to illustrate what is covering the land by that specific region. For example, it can be forest, it can be bare lands, it can be built up areas or developed areas, and so on and so forth. So basically, we can be able to perform that one in Google Earth Engine. And you can even do an app that monitors maybe a time series of how the land use land cover have been changing over time. Yeah, and then you do now the change detection and try to do the assessment of the same. Yeah, so I think I have tried to exhaust on that.
Okay, so thank you very much, Michael. You have mentioned some of the sessions which are forthcoming, because in
Yeah.
our curriculum next we are going to work on machine learning project, which is also in the curriculum. Next, one of these sessions we are going to have it
Don't tell me you're eating.
notes, and so we are going to teach you one of the days how machine learning and data science work together in the Google Earth Engine. And the most interesting thing with this is that using the cloud data, things are it is really important, because you can use it to work across projects, whether in finance, in manufacturing. Because I saw one of the projects that was done is that the Unilever, they are using Google Earth Engine and you see this is a manufacturing company. They are using Google Earth Engine to trace where some of their products are coming from. So everybody in each industry, despite the industry you are in, the satellite data is very important for decision making, for proper planning, for risk reductions, and also sustainable development of your business. So it really works really nice. You cannot overlook data in any industry you're working on. So we are going to have the Google Earth Engine application hubs, which now Michael has already mentioned. That is a session which is coming, but it's in the future days. Also, the machine learning part, he has also mentioned about that. We have a session on that. And we have other more sessions. We cannot reveal the next session what it will be about, but when we are going to launch the next poster, we are going to have the title posted. So you keep on checking on our blog, on our sites where you saw us. You please just keep rechecking. We'll be sharing more of these things. And now that we have our blog and we are going to have other social media platforms, this will be really much easy for you to follow, other than just seeing what I have. So I'm really much grateful on my side. I see it is now 5, and we are happy to have you, Sixing. Thank you so much, Sixing, for staying with us till this end. So we are really much grateful. Maybe for a few words here for the last word, anything you can tell us. You can share something from your side.
Can they see?
So I myself always want to visit Nairobi, Kenya. So after the pandemic, yes, because everybody is talking about the Serengeti, so Tanzania. So I always want to come to you guys. So and the language is of Swahili, and yeah, I want to climb the tallest mountain in Africa, the Kilimanjaro. So because the pandemic, I waited for 3 years, and now thank you for the invitation. Now I have a chance to talk to the colleagues now in Kenya, and I will come to you one day.
Karibu sana, karibu sana. Thank you so much. No, we'll need to send you a PDF for Kiswahili so that you can start learning.
Okay, cool. So
Yes. So,
Swahili Kilimanjaro.
yes,
Yeah, you're welcome. You're welcome.
we are going to share with you a Swahili PDF. So thank you very much.
Thank you. I love you guys.
Yes. Yeah, we really love you. So, did there be any question from the audience, any comment, anything you would love to share with us? Please, audience, this is your chance. You can say anything, please, to us.
So I have a question. Yeah.
Okay,
So
please.
regarding the first API, so is there any other platform you can use to create the API?
Yeah. So it's just a Python library. So let me show you again. So it's a very short. So in order to keep everybody quick. So it is a very simple thing, and you just need to have like install some libraries, and then you have to, however, for us, you need to have an ngrok. So it's like a URL. So a URL service. And once you have that, you just turn it on, and then the ngrok will give you a public URL, and then this URL will host all this fast API. So you can do everything on Google Colab for free. So it doesn't cost you any money, and ngrok will host this API for you. But I have to say, because it's free, it is not very fast. So the ngrok free version means that you will have like a very limited traffic. So not do this if you want to have like a production level cloud service. You better go to the cloud if you want to have like a more powerful machine. But to test the API, you can just test it right in the Colab with fast API. So everything is free, but not very performant. Yeah.
Okay. Thank you so much.
You can see this the code actually in my article in here. So it's in my PPT. I have the link, and in this article I've described everything. So how do you test it? How do you config the fast API and ngrok? Everything is in the article.
Okay, get it. Thank you. I look into it.
Thank you.
Okay, so anything from the members? Members, should you have any question, any comment, anything you will say, please.
So I think we have a question.
Yes, please.
So on the chart, how do you make a water change below the chart? Could you give some
How do
example
you
script
make
for
a
that?
water change below the chart? Could you give some examples before that? A water change. So you mean the thumbnails? So you mean this? You mean this? This is called a thumbnail. So it is basically a snapshot of each month. over the time. So as you can see here, oh no, in 3 months. So because I don't want to show so many pictures, and to do this, it's also in the script. So in this article, monitoring land use changes with Google Earth Engine. I have described how to do this. So it is in this control part. So you have like a thumbnail. So you sorry, the thumbnail function in here. It describes how it is implemented. So it's just a function with like 20 lines of code, and then you will have this here. That is just a snapshot of the area over time of the water.
Sure, then. Thank you.
Also, it's very helpful for you to see how is it the situation is correct, because sometimes you will see a lot of cloud. So that means the picture is not good, and then you should not trust the result, because if there are many clouds, it means that the land service cannot be monitored very effectively. So you can see the details on the thumbnail. So it helps to get an impression whether the data is good, and how good are the pictures.
Fantastic. Okay, so I think this is really nice, and we really appreciate. We have good positive comments which are appearing in the chat. People, members are appreciating the good presentation. So since you can be sure that you have done us proud, and we are really much happy, because
Okay,
we are really
thank
much
you.
happy. Yeah, the comment from our side, we are very much happy, appreciating the good work of Singing, the presence of you members, having spared your time to come and meet, share with us all this. Your presence here is really much appreciated, and we really appreciate your presence here. So thank you so much, and we wish you very nice. Anywhere you are in this part of the world, we are really grateful, and we look forward to seeing you next weekend on Saturday. We are going to have another similar event. Thank you so much, and you have a good day. Bye.
Thank you.
Good day. Thank you, guys. See
See
you.
you.
See you.
Yes,
Bye.
thank you, thank you.
See you.
Bye.
Yeah.